Hello again. In our last video, we reviewed the coordinate plane and discussed how every point is identified using an ordered pair such as X and Y. Now we are going to use that idea to answer an important question. How can we find the exact distance between 2 points on the coordinate plane? So let's begin with an example. So I have written here an example. Example 1, find the distance between point A, 2, and point B, 5. So the first thing you want to do is I want to plot both points on a coordinate plane. So the first thing you want to do is draw a coordinate plane. Okay. And since I'm dealing with numbers that are less than 6, I'm going to write my numbers as if 5 is the greatest of that number on each side. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay. Now, in doing that, this helps me understand the idea of values. Okay, this creates number sense. So we want to find the straight line between these 2 points that we're thinking about. So the first thing I'm going to do is I'm going to plot both points on the coordinate plane. So first of all, the first point says 0, 2. So that means I neither go left nor right with respect to the x for point A. It does have two values up the y-axis, two positive values. So this tells me that I'm going to be located right here. So that point, A, is located there. All right. The next point I'm going to plot is 0.45. 0.45 can be found by counting 4 units to the right. 1, 2, 3, 4. Here is where we would end. And then 5 units up. 1, 2, 3, 4, 5. And that would be where point B would be located. So now that I've plot both these points, I can connect them using a line, okay? Because I'm calculating the distance between these 2 points. But before using the distance formula, we got to understand where the formula actually comes from. So if we draw a horizontal line and a vertical line between these 2 points, we create what is called a right triangle. So watch this. So I know I was 4 units over, right? I was 4 units over here. So I can essentially draw a straight line right underneath that point and then draw a line down. And so notice what that creates. It creates a right triangle. All right. So if we draw a horizontal line and a vertical line between these 2 points, we create a right triangle. Now, the first thing you need to understand is this. This is a change in direction, right? So the horizontal change, is 4 minus 0, which equals 4, right? The change from 0 to 4, or 4 minus 0, would be 4. The vertical change, is 5 minus 2, which equals 3. The vertical change is 5 minus, oops, excuse me, 5 minus 2, which equals 3. Okay, so the change in distance from here to here is 3 units, if you can see it. So 1, 2, 3. There's 3 units that separate those two. So 3 units separate these two distances. And then here is separated by 4 units. Okay, so that's where those numbers come from. So the 4 and the 3 come from the distance between these two things. So the horizontal side has a length of 4, right? The horizontal side has a length of 4. If I were to sketch this triangle, this right triangle, the horizontal has a distance of 4 units, and the vertical has a distance of 3 units. All right? So the straight line distance between the 2 points, do you remember what this is called? That is called the hypotenuse. Okay? This might be coming back to some of you who have already discussed this in high school. Okay? So the straight line distance between the 2 points is the hypotenuse of this right triangle. Okay? To find the hypotenuse, we use what? We use what we call the Pythagorean theorem. Do you remember what the Pythagorean theorem is? The Pythagorean theorem is a squared plus b squared equals c squared. You said that, you are right on track. Great job. So the Pythagorean theorem is a squared plus b squared equals c squared. So what I'm going to do is I'm going to substitute the long and the short leg of this right triangle. Okay, so a is going to be my 4 squared, and b is going to be my 3 squared. And you don't necessarily have to put this in parentheses, I'm just doing it. Equals c squared. Okay, so 4 squared plus 3 squared equals c squared. Now in squaring this, remember 4 squared is 4 times 4 plus 3 times 3 equals essentially c times c. That's what this means. But don't get this confused, because many students err when they think about this. They say, well, 4 squared is, they'll say 8, because what they think they should do is 4 times 2 or 3 times 2. But what this is actually saying is 4 times 4, which gives me 16, and 3 times 3, which gives me 9. And I'm just going to restore that back to itself for now. So 16 plus 9 gives us 25. 25 equals c squared. Now from here, in order to get rid of a square unit, what we have to do is take the radical of both sides. When we take the radical of both sides, remember, when you reduce a radical that has a square unit in it, it becomes a single unit. This, when you simplify this, this is technically 5 times 5, as the same as this was c times c. So it simplifies perfectly to c equals 5. Therefore, the distance between the 2 points is 5 units. So notice something very important. The distance formula is not really a completely new idea. It is simply the Pythagorean theorem applied to the coordinate plane. So the distance formula is as follows. D equals the square root of x subscript 2 minus x subscript 1 squared plus y sub 2 minus y sub 1 squared. Now, here we have x sub 2 minus x sub 1. That represents the change in x, or the change in the horizontal distance of the two x values. And we have y sub 2 minus y sub 1, and that represents the vertical change. And then we square both changes, or excuse me, when we square both changes and then add them together, and then we take the square root of that, that is essentially how we solve the problem. So let's look at the problem that we just did. So we have the distance equals, so again, the points that we had originally are 4, 5, and 0, 2. So it doesn't matter the order that you put these in, okay? As a matter of fact, let me put them over here so that we can have them for reference. So we had A is 0, 2, and we had B, which is 4, 5, okay? And just for reference, as I mentioned, this is X, this is Y. This is X, this is Y. And it really doesn't matter what you use. You can say that's 1, and this is 1, this is 2, and this is 2, okay? Just to kind of give you a reference point. So when we put these values in here, again, it doesn't matter what order you choose. So I'm going to use x sub 2, which is parentheses 4 minus x sub 1, 0 squared. And that completes the change in x values. Moreover, y sub 2 is 5 minus y sub 1 is 2. And I'm going to square that. All right. Continuing on, we have d equals, so 4 minus 0 would be 4 squared, right? 5 minus 3, or excuse me, I keep saying that. 5 minus 2 would be 3 squared. This is 16 plus 9, root 25. And we know that the square root of a perfect number, 25 is a perfect number, that reduces to 5. So distance between these particular points is 5. So again, the distance between the 2 points is 5 units. So the picture helps us understand why the formula works. Why the formula works. The formula gives us a faster way to calculate it. So in the next video, we will use the distance formula with negative coordinates, where paying careful attention to detail and to signs becomes essentially very important.